For this tutorial, I would suggest switching your viewer to high definition. You can do so by clicking on this number. There's a number right in this area here that has a P next to it. Switch it to either 720 or to 1080p because there will be some small writing on this tutorial that you will need the higher resolution for. Okay, in the previous tutorial, we showed that this stepwise function here, this periodic stepwise function, was able to be modeled, mathematically modeled by a combination of cosine and sine functions. We showed that and also added to it was a constant a naught. We showed that a naught was equal to 0 at the tail end of the previous tutorial, and we also showed that the period was equal to 2 pi, because this function goes from negative pi to 0, which is a change of pi. This distance is pi, and then it goes pi again, and that's one full period. And so the distance of the period of one oscillation is 2 pi for this example. And so we set the period equal to 2 pi. For these generalized equations, now there are many forms of the generalized equations that you'll see out there in different books. This is my preference. I've seen a lot of different ways of writing it down, and I prefer this the best. This is my personal preference. If you find something that works better for you, that's fine. But I like this the best. Okay, so with this form, the way that you do it is you set the period of the function equal to 2L. Then L is equal to half the period of the function, whatever the period may be for that example. For this example, the period is equal to 2 pi, so L is equal to half of that, which is pi. Okay, so now we can just plug into these respective formulas to find these different coefficients and then just plug into this in the end. So A0, we already found that to be 0 at the tail end of the previous tutorial, so we've got this done, right? Now we'll go to A sub n. So it's A sub n, and notice it goes from n equals 1 to capital N, where capital N could conceivably go out to infinity in theory, but who has that amount of time, right? So we're going to do I think we're going to do 7, something like that. We'll see how the time goes. Okay, so let's start with A1. So A1, now we already discussed what all of these A's should come out to, because look, they involve cosines. So cosines are not good at modeling odd functions because a cosine function is an even function, and we don't use even functions to model odd functions. We use odd functions to model odd functions. So the sine function is going to be the most useful in modeling this function, not the cosine. And so we expect all the cosine terms to go away. And let's see if that happens. So let's go through the motions here. So 1 over L, so L is pi, so we have 1 over pi times the integral from negative pi to pi. You see, because it's 1 over L, and then from negative L to L, so negative pi to pi, because L is equal to pi, times f of x, and we're not putting f of x in yet, times the cosine of n pi x over L. Cosine n is 1 for this one. We're doing the first one, so this is 1 times pi divided by L, but L is pi, so we see the pi's are canceling, times x, like so. So we see these going away. And so this is equal to, now we're going to break this up because we have to integrate this stepwise function. We have to integrate it piecewise because it has this break in it, this sharp break in it right here. So we'll integrate from negative pi to 0, and then we'll add the integral from 0 to pi. So this will be 1 over pi, open bracket, integral from negative pi to 0, f of x from negative pi to 0, what is the function? The function's negative c. So let's put that in parentheses. Negative c times the cosine of x, because it's just 1 times x and the pi is canceled. And this is, let me clean this up a little bit. dx plus, I'm going to come underneath, 0 to pi, but from 0 to pi, the function is positive c. So we put that in. I always like to put the function value in parentheses just to remind myself to keep my bookkeeping notation correct. And this is times the cosine of x dx, close bracket, like so. Okay, so this is equal to 1 over pi times open bracket. Now, factor out this negative c, and we have the integral of cosine of x dx from negative pi to 0. And then factor out this positive c, and we have the integral of cosine x from 0 to pi. So let's take a look at the cosine function and see if we can do this quick by using symmetry. From negative pi to 0 is from here to here. I drew these tail ends right here just because it looks more sinusoidal. It looks funny. If you don't draw these in there, it doesn't look like a sinusoidal function. So I just drew that in there so it was more identifiable. But the function goes from here to here is the period involved. And so this part right here is negative, and this part is positive. So we see that on the interval from negative pi to 0, we have this negative area and this positive area to give 0. So this integral here, whenever this negative c is factored out, is going to give 0. So this whole term here is 0. Now we're going to integrate the cosine x from 0 to pi. Well, look, we start here and we integrate this way, right? So we have a positive area and this negative area, and they cancel to give 0, so this term is 0. So this is 0 plus 0, like that. This is 0, so 0 times this is 0. So this is equal to 0. So A1 is equal to 0. Okay? Let me make sure that made it in, and it did. Okay, next, A2. Well, here's the thing. Let's take a look at A2. We can make a generalized claim now. Because we know all of A's are going to be equal to 0. A2 is going to involve the cosine of 2x, right? Because look, this number here, this is the n, this becomes a 2, the pi's cancel again, so it's going to involve the cosine of 2x. Well, that means you're taking two wavelengths, two periods, if you will, and shoving them in to the same interval, right? To this interval from negative pi to positive pi. And whenever you do that, you're going to have this same business going on with the areas canceling. And those integrals are going to be equal to 0. So the integral of cosine 2x from negative pi to 0 is 0. And the integral of cosine 2x from 0 to pi is 0. So, and it's true for A2, it's true for A3, A4, A5, it's true for all of them. Dot, 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 A sub n, all of those are equal to 0. So, we're done with A sub n. Bang. Now B sub n. These will not all be equal to 0. Okay, so that's why I've left as much space as possible. So let's move on to the B's. Again, I'm going to step out of the way, and let's do B1. B1 will be equal to 1 over pi. Negative pi to pi. F of x, we're writing it in general first, times the sine of n pi over L times x. N is 1. You see this? We're dealing with the first one. So this is 1 times pi divided by pi, because L is pi, times x dx. So this is canceling, bang, bang. And we see that this is just the sine of x in here. So now we're going to break the integral up and integrate piecewise as before. So 1 over pi, open bracket, from negative pi to 0. And over that interval, the function is equal to negative c. And this is times the sine of x dx, like so, plus the integral from 0 to pi c times the sine of x dx, so, like so. Close bracket. Okay, so here we go. from negative pi to 0, take a look at the function. From negative pi to 0, this is just the sine of x. So from here to here, we have a negative area. And that number comes out to be 2. So what we have is this. We have 1 over pi. We have negative c. This thing factored out in front right here. Negative c, and that whole integral comes out to be negative 2. Right? Because it's below the x-axis. Plus, and then the integral, this c factors out, the integral of sine x from 0 to pi is, from 0 to pi is 2. And not 0 to 2 pi, it's 0 going to pi. So this is 2. So you see these negatives canceling? So now we have 2c plus 2c is 4c. We have 4c over pi. Okay, so that's our first b. Let's do b2. Okay, so b2. Now we're doing the second one for this. 1 over pi. Integral from, and now we're going to break it up right away. We're just going to start breaking it up right away because we know we're going to have to anyway. Negative L to L, so we're going from negative pi to 0, and then we're adding 0 to pi. So let's go from negative pi to 0. Over that interval, the function value is negative c times the sine of n pi over L. Well, n for this one, this is the second b. So this is 2 pi over pi. The pi's are canceling. The pi's are always canceling. So that's going to happen every time for this problem. So it's going to be 2x. Okay? Plus, from 0 to pi, c, because the function value is positive c over that interval, times the sine of 2x dx, close bracket. Okay. This is equal to. Okay, now, if we evaluate this integral and this integral, we will achieve, and let me check this to make absolutely sure. For sure it's 0. It is. It will be 0. Now, there's a way to think about this. I'll show you how to think about this. So what we got to do, now we have to break this up. Okay, so we're going to draw the sine function on this axis. But you see that this is sine of 2x. See, sine of x had one wavelength in there. But now, because it's sine of 2x, there's going to be 2 wavelengths in there. So watch this. So this is from right here to right here. So now 2 wavelengths have to fit in there. So it's going to go like that. And like that, right? Then when you integrate from negative pi to 0, this negative c factors out. And look, this is negative pi right here, and this is 0. You've got an area above and an area below, 0. So this term is 0. And look, when you integrate from 0 to pi, you got a positive area and a negative area. They're equal in magnitude, but opposite in sign. 0. Okay? So I'm going to save some space here. That's equal to 0. B3 equals 1 over pi. 0, negative pi to 0, negative c times the sine of 3x, because we have a 3 now. Pi's cancel always for this example. Sine of 3x dx. Oh, notice I forgot to put the dx here. Did I make that mistake anywhere else? No, I got it there. Yeah, we're good. Okay, I just forgot to put the dx right there. Okay, plus from 0 to pi, positive c, sine of 3x dx, close bracket, like so. Okay, so we're all big boys and girls at this point, right? So we can integrate. The negative c factors out, and then we integrate the sine of 3x. Now look, now there's not two wavelengths being packed into that same space. There's three wavelengths. Okay? So let's take this thing. Let's see if we can figure it out by looking. So from here to here, but this entire interval, three wavelengths has to fit into it. So we have to break it up into three parts. So we see this part, and this part. One wavelength needs to fit into each of those. So let's go. And this needs to come. It needs to be turning quicker than that. Okay, there it is. Okay, here's the thing though. We integrate from, and you might think, oh look, there's 1, 2, 3 above, 1, 2, 3 below, 0. But no, because you're integrating piecewise from negative pi to 0 and then from 0 to pi. So notice when you go from negative pi to 0, you have below, above, below. So this one this one cancels with this one, but this one remains, right? And that value is, so we have 1 over pi. Sorry about the length, guys. It's Fourier analysis. This is as fast as she blows. It's tedious. You just got to work it out. You know, if you got an exam, I suggest practicing this because you want to be well practiced. Okay, so for B3, let's see here. This number here, this will be negative c, and this number will be negative 2/3 when you carry out the integration. And then we have plus positive c times positive 2/3. Because look what happens on the other side. You have 2 above. When you go from 0 to pi, you have this one, both of these above and this one below. So this one, you can cancel with this one, but you're still left with this one above. So, and the value of the area above right here is 2/3. So B3 is equal to, we have these negatives cancel, so we have 2/3 c plus 2/3 c, which is 2 plus 2, 4c, 4c over 3 pi. So this is 4c over 3 pi. Let me check that, and that is correct. Okay, B4. Now, I'm going to jump ahead a little bit. You could carry out the integration as before. The even b's, the B2, B4, B6, B8, and on are 0. Okay? So B4 is equal to B6, equal to B8, dot, 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 you know. And let's just put it out to 8. That's fine. 0. We get the idea. All the even b's are 0. But the odd b's are not. Okay? So B5, I'll tell you what I'm going to do. Let's see here. Yeah, I'm going to have to do some erasing. Goodbye to these guys. So we get the intuitive idea, right? We get how, you know, you're squishing wavelengths into the same space. So now we're going analytical. Okay, so B5 is equal to 1 over pi, and then this will be integral from negative pi to 0, negative c times the sine of 5x dx plus integral from 0 to pi, positive c, sine of 5x dx, close bracket. This will be equal to 1 over pi. Okay, you see that we have the negative c over this interval, positive c. The 5 is here because this is B5, right? We did B2, B3, B3, you know, we did B2, B3, B4, and all the evens. And then these numbers are B5, for B5, it will be negative C times negative 2/5 plus C times 2/5. Like this. And this number is 4C over 5 pi. Okay, here we go. B6, 0, B7. Okay, one more. B7 is equal to 1 over pi. And we're going to run out of space. So I'll tell you what I'm going to do. I'm not going to write down the integration. I'm going to write down the answer, but I'm going to write down the numbers in between. So, and you know it's good, these calculators, because you can just do all these integrations in here, and you avoid errors this way. It's a good idea to have some symbolic manipulating computer at your disposal. So this will be negative C times, so I would encourage you to work this problem because you know it's correct. This problem did not get up online if I did not check it first, and I had other people check it. So this problem is definitely correct. 2/7. If it's not correct, we'd redo them. 4C over 7 pi. Are you starting to see the pattern? Look, B3, let's see, B1, 4C over pi. This is 1 times pi, isn't it? And look, B3 is 4C over 3 pi. So look, it's basically, this is equal to 1/3 times 4C over pi. And then this is equal to 1/5 times 4C over pi. Do you see that?